What is a definite integral and how it is related to areas? A definite integration is a math concept used to determine the value of areas limited by curves and straights. Integration can be used to find areas, volumes, central points, and many other things. The most common use is to find the area under the graph of a function. What is the Riemann method? It is the method in which you have to draw imaginary rectangles inside the shaded area you want to calculate it, the area. Then you have to see the height or width of the rectangle, and then tabulate equations to get the other value. Isn't it clear yet? Let's see an example.
Well, this is the example. The red area is the one you want to calculate. And on the next side, you can see the charts and the graphs below.
To use the Riemann method, you must divide the area under the curve into 4 or 5 columns. Then you have to check the value of the columns within and make sure if the same for all of them, but taking the value of the left line of the column. Make a tabulation chart with those values, and if it's with y-axis, make sure to use the y-axis values. And then use the value of the within of each of the columns to plug it into the original function. After finishing evaluating, add all the x or y values depending of which axis you are. Multiply that sum times the value of the distance between each column, example 0.2, 0.5, etc. If there is a triangle area, you must add the value of its area to the multiplication that we previously have made. For right and middle rectangles, repeat steps all the previous mentioned, except number 2. For the step, if it's with right rectangle, you must take the values of the right line of the column of rectangle. If it's with the middle rectangle, you have to divide each rectangle into half and use the value. Then you can follow all the same steps. You can also calculate the exact shaded area with integrals. To follow this method, you have to see the limits given, and if you are doing with respect to the y-axis, isolate y, integrate the function, and evaluate with respect of the biggest number in the integrated function, and then evaluate with the smallest number and subtract the result to the first one. Let's solve the same example with this method. When you use the integration method in respect to y, you have to isolate y and integrate it. Then you evaluate in the integral with the bigger number and subtract it the result of evaluating the integral with the smallest number. Just like this example, because if you do an example with respect to the x-axis, integrate the original equation.
Now that you understand the topic, let's do some practice. You can pause the video and solve the next exercises and see the answers.
In conclusion, we can say that the calculus can be applied in different areas. Some of them are administration, economy, physics, etc. It is used because it has tools such as system of equation, derivatives, functions, the slope, among others. The main application of the differential calculus are the study of movement, aspect of speed and acceleration, analysis of equation with binomials, and the calculation of maximum and minimum. We conclude that the most important application of the calculation is to calculate the profits or losses of a company. We also think that this project helps us to understand that daily life is full of implicit calculus. That means that many activities like the ones we mentioned before, and we didn't have a clue of that.